Hey guys, welcome back to my channel. In this video, I'm going to be continuing the series where I attempt IB Chemistry HL questions on camera with you guys so that you guys can understand my thought process and attempt these questions yourselves. Based on the feedback I've received from my previous videos, it seems that you guys are finding these videos really helpful, so I decided to continue this series moving forward. Before we get started, I'd like to mention that this channel is quite new and it's still emerging, so any form of support, whether it's a like, subscription, or a comment, is highly appreciated on my behalf. And if you guys are enjoying my content and are finding it helpful in your revision for IB, please do like, subscribe, and comment down below. And without further ado, let's get started with the questions. Which compound has the greatest percentage by mass of nitrogen atoms? So for this question, since we're calculating a percentage by mass and finding which one's greatest, it's best to calculate the numbers for each one and then work out the final answer. So for this one, we have two nitrogens, which is going to be approximately 28 atomic mass units, and the total molecule is going to be 28 plus 4, so that's going to be 32. So that's going to be about 7/8. That's about 0.875, I believe. So, or 87.5%. So these are just fractions that you need to know. So I'm able to convert that. Next one we have, this one's going to be nitrogen, is going to be 14, and 3 hydrogen 17, so 14 over 17. Next one, nitrogen 2 and oxygen 4. I know that this is definitely not going to be it because for these two, we've had more than half the percentage mass being nitrogen, whereas for this one, we know that oxygen has a higher atomic mass than nitrogen, and the fact that we have more oxygen atoms in this molecule than nitrogen already tells me that the percentage by mass for nitrogen will be less than a half, so this one's not it. Again, for this question, we have much more non-nitrogen mass than nitrogen mass, so I can eliminate this option as well. From comparing these two options, it is safe to say that 14 over so it's 14 over 17 and 28 over 32. You might think, since I've converted to 7 over 8, how do I compare which one's bigger without a calculator? Well, the cool thing here is you see 14 and 28. 14 times 2 is 28, so if we multiply both sides by 2, both the numerator and the denominator, we get 28 on 34. So that's the equivalent fraction for the percentage by mass, or the mass composition of nitrogen in this molecule. So here we have 28 over 32 and we have 28 over 34. Which one's bigger? It's obviously A, 28 over 32. So our final answer for this question, which one has the greatest mass percentage of nitrogen atoms, would be A. Which statements about mixtures are correct? The components may be elements or compounds. That's correct. All components must be in the same phase. That's not true because you can have homogeneous or heterogeneous mixtures. The components retain their individual properties. That is indeed correct. So B is our correct answer. What is the expression for the volume of hydrogen gas in cubic decimeters produced at STP when 30 grams of magnesium reacts with excess hydrochloric acid? So 30 grams of magnesium would be the limiting reactant. Okay, so that's the limiting reactant, and I guess the molar mass of magnesium would be 24.31 because I see that in the denominator here. So the moles of magnesium would be 0.30 divided by 24.31. So the limiting reactant here, what's that? Yeah. So the limiting reactant here would be the one that determines the amount of product that can be formed, which hydro hydrogen gas. So we're meant to determine the volume of hydrogen gas, which is the product, and this will be based on the limiting reactant, which is magnesium. So if we have 1 mole of this, we should have 1 mole of this being formed because there's a one-to-one stoichiometric coefficient between them. So we need to find the volume. And the volume we know is just going to be moles times molar volume, which in this case is going to be 0.30 times 24.31, which is the moles of magnesium and also the moles of hydrogen gas that will be produced. And the molar volume at STP will be 22.7. So it's going to be that. So we can rewrite this as this 0.30 times 22.7 over 24.31. And if we look at our answer options, it seems that this is our correct answer, B. What is the order of decreasing ionic radius? So ionic radius decreasing should be testing your knowledge on ionic radius trends in the periodic table. So what we know first of all is that if we have the same electron configuration, so essentially when we form ions, we're going to have a noble gas configuration. Noble gas configuration. So if period 3 halogens form an ion, say chlorine forms an ion, that'll be an argon nucleus, argon electron configuration, because that's going to have enough electrons such that it basically has the same electron configuration as argon. Similarly, if you have sodium that's being, sorry, not sodium, potassium, if we have potassium losing an electron to form a +1 cation, then that's going to also have the same electron configuration as argon. However, um, based on the fact that potassium has more protons than um, than chlorine, this is going to have a greater nuclear charge. Nuclear charge is greater. So if nuclear charge is greater, we have stronger pull. So the K plus ion should be smaller. Similarly, the Cl minus ion would have more inter-electron repulsion as well, so it's going to be bigger. So generally, positive ions are smaller than negative ions if the noble gas configuration, the same noble gas configuration is achieved across these cations and anions. For this question, it is safe to say that you should use the periodic table given at the front of your paper 1 booklet. Okay, so the important thing to recognize in this question is also that the same ions are used throughout. So if we identify which of these is going to be bigger and smaller than each other, then we can determine which answer option is correct. So here we see that all of these have the same electron configuration, so they're all going to be they're going to all have the electron configuration of argon as a noble gas. So they all have the argon configuration. So the next we can order these from from the atoms with the most from the least to the most protons. So sulfur has the least, followed by chlorine, then magnesium, then aluminium. So based on this, we can work out the nuclear charge. So if the nuclear charge for sulfur is lower than chlorine, then that means sulfur will have less of a strong pull, less of a strong pull between the nucleus and the outer electron clouds. So a weaker pull with the outer electron clouds means that sulfur will have a larger ionic radius. So sulfur is going to be larger than chlorine. And already we can eliminate any options where the positive ions are larger than the negative ions, because as we previously discussed, if they're the same noble gas configuration, then the negative ions are going to be bigger than the positive ions. So again, sulfur has to be the biggest because sulfur is going to be bigger than chlorine. Next, we think about aluminium and magnesium. Aluminium has more protons, so greater nuclear charge, greater pull than magnesium, so it's going to pull its outer electron cloud closer. So this one, aluminium is going to have a smaller ionic radius, so aluminium has to be on the end. So option C is our correct answer. Which oxide, when added to water, produces a solution with the highest pH? So highest pH means most basic. So if we think about most basic, we can think about which of these would dissolve. So first of all, we know that the sulfate, so sulfur trioxide, sorry, dissolves in water to form sulfuric acid. So this is not going to be an option because we're going to get an acid which has a low pH because acidic means low pH. Same with carbon dioxide. Carbon dioxide dissolving leads to carbonic acid, which again is an acid and low pH. Next, we're wandering between um, sodium oxide and magnesium oxide. Well, think about which of these produces the stronger hydroxide, whether it's magnesium hydroxide or sodium hydroxide. Whenever we have a metal oxide reacting in solution, we form reacting with water. Sorry, when it's added to water, we have a hydroxide, metal hydroxide being formed. The fact that we have sodium and magnesium means that we're going to get sodium hydroxide and magnesium hydroxide. So which of these do you think is a stronger base? Well, the stronger base is sodium hydroxide because sodium hydroxide, we know it's something we have to know in IB chemistry as being one of those super strong bases. And magnesium oxide is more of a salt that's got weaker basic properties. So it's not going to have that much hydrolysis. If you guys don't know what hydrolysis is or want to know more about it, please check out my salt hydrolysis video. It'll clear up this stuff about weak and strong acids and bases. So other than that, A is our correct answer. Which electron transition in hydrogen atom emission spectrum emits radiation within the longest wavelength? Well, if we're talking about longest wavelength, we're talking about the smallest energy, right? Because energy and wavelength are inversely proportional. So if we talk about smallest energy, then we're talking about infrared radiation. And infrared radiation is going to be one of the three transitions which produces the um the smallest transition, smallest downward movement. So already we can eliminate this one because we have an upward transition. So if we're an upward transition from energy level 1 to 2, then we're absorbing light, so absorbing radiation, so it wouldn't be emitting. So we can narrow down to options A, C, and D. Normally, if you remember the Lyman, Bolmer, and Paschen theories, which is not necessarily in the syllabus, but it's good to remember, you'd notice that the Paschen series is to do with infrared radiation, and this one. So actually, let me clear this up. So you have UV, that's more than visible, and that's more than infrared. So this is in terms of energy, right? And if we're talking about wavelength, then it's going to be UV, visible, infrared. So this is in terms of wavelength, and this is in terms of energy. So since we're talking about the longest wavelength, we're going to talk about smallest energy. Infrared light energy or radiation is emitted when we're transitioning down to energy level 3. However, since we don't have a transition to energy level 3, we can think about the next best one, which is visible light, which is energy level 2. If you've probably already guessed, ultraviolet is energy level 1. So since this is going to be the smallest energy or the longest wavelength out of these ones, which is the visible compared to ultraviolet, we can eliminate this one and this one because both of these are going to emit ultraviolet light, which is going to be of relatively shorter wavelength and higher energy than this one here, which is going to be of visible light. So D is going to be our correct answer. Which statement explains one of the decreases in first ionization energy across period 3? Um, okay. So here, first ionization energy should generally increase across a period. So the idea is why is it decreasing here? That's why it's asking. So we see the decrease here from magnesium to aluminium. That's probably the most distinguishable. And if you guys know anything about electron orbitals, we know that sodium and magnesium are in the s block of the periodic table. So the valence electrons are in the s orbital, whereas these ones are all in the p orbital. And here we have another decrease as well. The nuclear charge of element Al is greater than element Mg. Well, that doesn't explain why ionization energy should go down because, if anything, if nuclear charge is greater, there's greater pull on the electron, so more energy would be needed to remove those electrons, hence having a higher first ionization energy. So A is incorrect. The electron-electron repulsion is greater for the element with opposite spin in S than element P. This could be correct because when you go from P to S, we're going from this. So pretend these are I believe this is 3p orbitals, 1, 2, 3. So for phosphorus, we have singly occupied orbitals as according to the Hund's rule. And as soon as we go to sulfur, we actually have this doubly occupied orbital. when you have doubly occupied orbitals, you have electron-electron repulsion. And when you have electron-electron repulsion, it's easier to remove an electron, and hence the first ionization energy is going to be lower. So this seems to be the correct answer. But let's check if there are better options. A new sublevel is being filled at element S. That's not true. It's still the p sublevel. The p orbital filled in aluminium Al is a lower energy than s orbital in element Mg. Well, this is correct in terms of saying that this is the p orbital. P orbital is in Al, and the s orbital is in Mg. But I believe that the p orbital is actually higher energy, so this statement itself is incorrect. The whole statement is incorrect, so D is not going to be our answer. B seems to be the correct answer for this question. What is the charge on the iron 3 complex in? Okay, so iron 3 complex, since we're getting a Roman numeral number, the oxidation number, then we know that this is going to be Fe3 plus. And for each hydroxide ion, we have -1 charge. Since we have 2, we have a -2 charge. Water does not contribute any charge as it is a neutral molecule. So our final charge is going to be 3 minus 2, which is going to be 1. So +1 is going to be the charge on this complex ion. A substance has the following properties: melting point of that, molten, poor conductor, solid, poor conductor. What's the most probable structure for this substance? For this question, I'm thinking more eliminating the structures as I go by. I know that's not going to be metal because for one solid, it has poor conductivity. It's not going to be ionic because ionic substances, when they're molten, have good electrical conductivity because of free moving ionic charges. I believe that because the melting point is quite high, it's not going to be polar covalent because covalent substances generally don't have this high of a melting point. And it makes sense that it is network covalent because we have these non-conductive properties and we have a decently high melting point, which is characteristic of network covalent or giant covalent structures. Which two atoms form the most polar bond? Most polar bond is in terms of difference in electronegativity. So if we think about differences in electronegativity, electronegativity basically increases that way across the periodic table. So left to right and down to up. That's why fluorine is the highest. So next we look at carbon. So we see that fluorine and chlorine are going to be the high electronegativity items in this polar bond, this hypothetical polar bond. So these halogens are going to be the high ones. But since we're looking at the most polar bond, we got to look at the biggest difference. Well, the biggest difference would be something with fluorine rather than chlorine because fluorine has a higher electronegativity than chlorine, and fluorine and chlorine in these hypothetical bonds are going to be the ones that have the higher electronegativity because carbon and silicon, I know for a fact, have lower electronegativities than fluorine and chlorine. But the fact that we have fluorine and fluorine has the high electronegativity, we can eliminate the chlorine options. So we're going to be left with carbon and fluorine and silicon and fluorine. We're going to think about between carbon and silicon, which one has the smaller electronegativity, because fluorine has the larger one. We've got to find out how we can maximize this difference in electronegativity. So carbon is going to be above silicon in the periodic table, directly above. So there's not going to be a horizontal difference, but there is going to be a vertical difference. And that's going to be that carbon has a higher electronegativity than silicon. So that means that this difference in electronegativity is going to be smaller than this one. So this is going to be the larger difference in electronegativity, hence the most polar bond. So we're going to go with C as our answer. Which combination describes this ion? Well, pH plus. We're going to try and draw it out. First, we need to calculate the number of valence electrons. Phosphorus has 5 electrons, and each hydrogen has 1, so we have 4. And we're going to take 1 away because of the positive charge, so we're going to be left with 8 electrons. Next, let's draw this out. There we go. And let's see if we had the total number of electrons. 1, 2, 3, 4 electron pairs, which is going to be 4 times 2, 8 electrons. So tetrahedral seems to work. It's not going to be square planar because molecular geometry of square planar means that we have 6 electron domains to get octahedral electron domain geometry. So these aren't it. And if we have tetrahedral electron, a molecular geometry, sorry, or electron geometry, we're gonna have a hybridization of sp3. We can't have sp2 with tetrahedral. So C is eliminated. So A is the correct answer. This VSEPR theory stuff is quite complicated, and if you guys do want me to make a video on this, I really like VSEPR theory, and I think I can explain it quite well. So if you guys do want to see a video on that, please leave a comment down below, and it'll notify to me whether you guys do actually want to see a video of this type, and I will make sure to make a video on it soon enough. But without further ado, let's move on to the next question. Which combination describes the bonding and structure in benzoic acid? So this is benzoic acid. We have the benzene part, and then we have the carboxylic acid part. The number of electron domains per carbon atom. Okay, so it looks to me like it's a bit confusing. Number of electron domains per carbon atom. Okay. Okay, so each carbon atom in this molecule must have the same number of electron domains. So I can just assume this one is the carbon I'm going to use. We have 1, 2, 3 electron domains. So we can eliminate these options. Let's look at the number of pi electrons. We can check the double bonds. This is 1 pi electron. And remember, benzene is a resonance structure that has pretty much 3 double bonds that are alternating. So we have 1, 2, 3, 4 pi bonds, and because of that, each pi bond contains 2 electrons, so we have 8 total pi electrons. So even without looking at this number of sigma bonds, we can already tell that B is going to be the correct answer. Also, we can easily eliminate A as the correct answer option because the number of pi electrons and number of sigma bonds. Oh wait, that could be slightly even. Wait, actually. No, never mind. I don't think I should second guess myself. So the number, this is the number of pi bonds. I thought it, number of sigma bonds, sorry. I thought that said the number of sigma electrons, which in this case would be noticeably more than the number of pi electrons. But given that it is the number of sigma bonds, then it's sort of believable that A could be the answer. But because of the number of pi electrons being 8, we can eliminate option A. And since we eliminated options C and D based on the number of electron domains per carbon atom, we can get B as our final answer. Which species have resonance structures? Resonance structures mean that there are multiple Lewis structures and there's going to be delocalized electrons. Ozone does have one, benzene does have one, carbon dioxide does not. Carbon dioxide is a simple molecule, it's like that. Like that. So oxygen has 2. So it's going to be 1 and 3. So that as our final answer. Which expression gives the mass in grams of ethanol required to produce this much of heat upon complete combustion? So it looks like we have this much energy released, this many kilojoules of energy released whenever we have a mole of ethanol combusted. And it looks like this number is actually exactly half of this number. So we need half a mole of ethanol to be burnt, but the actual calculation is going to be something like this: 683.5 over 1367. That's how many moles of ethanol we need. And to find the number of grams, we need to multiply that by the molar mass, which is 46.0. So 46.0 is going to appear in the numerator, and looks like we're going to get something like this. And this looks an awful lot similar to option C. So option C is going to be our correct answer. Which expression gives the enthalpy change for the thermal decomposition of calcium carbonate? So calcium carbonate to calcium oxide and carbon dioxide. Okay, so we have hydrochloric acid, and we have delta H1, delta H2. So if we're talking about the thermal decomposition of calcium carbonate, it's going to be delta H, I believe. Okay, so delta H. Now, if we look at Hess's law, that says that if the starting and ending conditions of a reaction are the same, then the enthalpy change will be the same regardless of the steps taken. So here we see that for us to end, this is basically the start, and this is the finish. For us to end up at the finished molecule, we can follow this path and the backwards of this part. So if we look at the backwards of this part, we just have to put a negative there. So our final answer is going to be delta H minus delta H1, sorry, delta H. This delta H is going to be equal to delta H1 minus delta H2. But I'm just going to look at why there's a 2 in front as the coefficient. Now, I don't think that makes a difference here, so I don't think the 2 is meant to be there. So I think A is the correct answer for this question. Which equation represents enthalpy of hydration? Enthalpy of hydration starts off with ions, so we can eliminate these options. B is the correct answer. Which combination of delta H and delta S result in a non-spontaneous reaction at all temperatures? Delta G determines spontaneity, and it's defined as delta H minus T delta S. And delta G, when it's positive, delta G positive is going to be non-spontaneous, so non-spontaneous. And delta G is positive means that delta H is going to be positive as well. Since we're subtracting minus T delta S should be negative because the negative delta S that's taken the negative off will be positive. So we're going to get as positive. We're going to get this delta H as much positive as we can to find when it's non-spontaneous. So the negative will be the answer. So A is the correct answer. And if that's confusing, I recommend you guys look over some delta G stuff and the formulas. It's just about being familiar with how formulas work in mathematics, and just looking at it for a while will help you guys. So just rewatch this explanation right here. You should be able to catch it. If you guys don't, leave a comment down below and I'll get to it. Copper catalyzes the reaction between zinc and dilute sulfuric acid. So we have zinc solid, sulfuric acid, and we have this equation. Why does copper affect the reaction? What is copper? Why does copper affect it? Isn't it how does copper affect the reaction? I believe that's a wording error. But I think, well, if it's a catalyst, right? If it catalyzes something, then copper's a catalyst, so it would decrease the activation energy. That's what catalyst does. So A seems to be the correct answer. 100 cubic centimeters of 10% hydrogen peroxide solution decomposes to form water and oxygen. Dotted line represents the volume of oxygen produced, volume of oxygen time. Which graph represents the decomposition of an equal 20% solution under the same conditions? So if we have equal volume, that's going to be this much, and a 20% solution would be higher concentration. So if this is the equation, and we have the same volume and actually double the concentration, then we're going to get, since the number of moles is concentration times volume, the concentration stays the same, but we double the volume, we're going to get overall 2 times the original amount. So if this is the original curve, well, the only curve that's possible is going to be this one, because the total amount of oxygen gas produced should be double the original amount here. So A seems to be the correct answer. The table gives rate data for the reaction in a suitable solvent. So we have C4H9Br, whatever that is, that's probably like butane, bromobutane, or something like that, and something bromobutane, I don't know, 1, 2, whatever. And we have the hydroxide ion to form a alcohol and the bromide ion. So this is where we have to work out the rate expression. So we have the initial rate, and we see that when OH1 is kept constant and we double this, we actually double the rate. So it's going to be first order with respect to this one, because doubling the reaction, doubling the concentration of this doubles the rate. So it's a 1-to-1 or proportional change. Here we have this thing kept the same, but we're doubling it and we have no change. So from here to here, we're keeping it the same, we're doubling it, and we have no change. Therefore, it's going to be 0 order with respect to that. So it's going to be 0 order with respect to this, so we can eliminate this option here, and we can eliminate this option there. We can draw out C4H9Br, but actually given that, okay, so the rate expression had 1 concentration in it, so if it has 1 concentration in the rate equation, I believe that's going to be the SN SN1 mechanism. I believe the SN2 mechanism, which is for primary halogen-alkanes, this would be SN2, has two concentrations in the rate expression. So I believe that D is going to be the right answer because the SN1 mechanism only has one. Since the concentration, since we're zero order with respect to this one, then we're going to get this as our, so we're going to get a rate constant like this, rate equation like this. C4H9 Br1. There we go. So if we're only affected by the concentration of the of the hydrocarbon, the halogenoalkane. So we're gonna have to um, consider that this is the SN1 mechanism. The SN1 mechanism where it is only dependent on the concentration of the halogenoalkane and not the concentration of the hydroxide ion. So I believe D is the correct answer. So guys, upon looking at the answers for the first 20 questions that we attempted, it seems we got 20 out of 20. So super well done, but let's not get too egotistic here because those are the first 20 questions essentially, or the easiest ones in the paper one question. So when I attempt with you guys, the next 20 questions in this past paper, on camera and in future video, may not get as high of a mark, so we shouldn't get too cocky with this result. So generally, even though it's not official, or it might be, I believe that the difficulty of the question sort of goes up as you progress through paper one. So attempting the first 20, you should aim for about 20 out of 20, maybe miss out on one at most if you want to get a really high score. So other than that, guys, hopefully you enjoyed this video and learned something new and found this helpful in your revision for IB chemistry. And if you guys did so, don't forget to smash that like button and leave a comment down below saying you guys enjoyed the video or have any suggestions for future videos that you want me to make. Also, remember that this channel is quite small and any subscription is highly appreciated. Like if you subscribe to one of those 1 million accounts, they probably won't see you at all. I'm not saying you shouldn't, but for me, I count my subscribers every day. I check them, and every time I get one new subscriber, it makes a huge difference in my life. So that's a bit sentimental, but hopefully you guys enjoyed this video. See you in a future video. Peace out.